Hello and welcome to the next part of this first-person shooter tutorial in Unity. Today we'll be having a look at how we can improve some of the mechanics that we've already implemented in the previous sections of this particular YouTube tutorial series. We've already got our character that is moving around in first person. We can look around with the mouse, we can move around with WASD, and we can shoot at things. Last time we were looking at how we can create a little bit of sort of actual gameplay, or like a start point, a finish point, and the success and failure. So we're going through this door, the timer starting, and you can see the timer on the top of our screen. We're going to shoot at these targets, and then as we hit the targets, or if we miss, nothing happens, but if we hit the targets, then that little red number goes up, which is displaying how many people we've shot. And once we've shot 6, whenever we go into this timer box, we then have our score, which is how much time it took, in this case 17. So we've got a little bit of gameplay. Now what I want to do is introduce you to a new idea, a new concept within coding called ray casting, and then we're also going to improve the shooting mechanics. So one of the problems with the shooting mechanics at the moment, or one of the things that I'm not a fan of, is the fact that whenever you shoot these projectiles, they come essentially out of your face. Now maybe this could represent something like beams of ray gun or something, that your Colossus style from the X-Men just coming out of your eyes, or like Superman or something. But ultimately what we want to do is I'm going to demonstrate to try and create more of a sort of firearms perspective. So instead of the thing coming right out of our eyes, between our eyes, which is going to be in the center of the camera, we want the projectile to come somewhere slightly different. So I'm going to go ahead and create a really simple gun, as it were, for our character. We're going to move this cube, and we're going to like space it out. So this can be the basic shape of our gun, and we're going to have to try to move it around and make it a child of our camera, and I'll show you why you want to do that and what we're trying to achieve here. So let's go ahead and find our camera in the scene. The hierarchy is pretty messy at the moment. We could do a better job of sorting this out, but for now we're just going to try and find the camera. Let's see, so here's the player, and here's the main camera attached to it. And we're going to want to attach this cube as a child of the main camera by dragging it in like that. We can even rename this gun so we can start organizing things a little bit. And really what we're going to do here is we're going to look at where the main camera is. So you can see here, I can see it's pointing. I just pressed on the main camera and clicked F so I can sort of see a focused view of it all. And we're going to want to position our gun relative to that. So that it's sort of inside our perspective, and you can kind of see it appearing in our scene. Right here it is here. So we've got this gun pointing towards the direction that we would be firing our gun. So I'm going to position it sort of roughly here. I'm going to play the game and see how that looks, and you'll notice that because the gun is a child of our camera, wherever we rotate the camera, the child will rotate as well, because it's being set relative. So we're sort of giving the illusion that we're firing this gun, but the projectors are still coming out of our head and they sort of flash on the screen. So now what we want to do is we want the projectiles to come out of the gun, but we still want the projectiles to hit whatever it is that's in the center of our screen, where our little crosshair is, or this little dot. And so what we really want is we want our projectile to come out of the gun, but to hit this particular position. So to do that, we're going to have to use ray casting. So I'm going to explain what ray casting is. And it's essentially like sending out a little sensor. If you have this sort of start position here, and then you imagine that you're going to send out a little sensor. You've got a start position, which is this, and then you've also got a direction, which is the direction coming from that position. And this little sensor will be sending out, will be shoot out from your position that you're starting from, and wherever it hits something, like let's say there is this large wall, then if it is checking to see if it hits something, it will then, the raycast will then say, okay, well this is the point at which the raycast hit an object, a physical object that it collided with. So that means that if you have a different angle, for example, you have a different direction, then it will be a different point. This will be the point here that it the raycast collides, and this will be the point depending on this angle. And we can also have a completely different position. Like for example, maybe we start here and we have this direction, in which case the raycast doesn't hit anything because it goes over the wall, and so on. And so the point of this is for whenever we fire the gun, if we imagine that this is where let's use this black. and this brush. So if this is where our camera is, and then our gun is like in a lower down position, slightly offset from our camera, wherever our wall is, let's say here, or our target, or whatever it is we're shooting at and we're hitting, we're going to want to do a ray cast target from the perspective of let's see, draw a line of our camera, and it's going to hit whatever it's looking at, like this. Can I change this to red, please? Oh, color one. I need to change to red. There we go. So our ray cast target is coming out here, and then it's hitting this position here. And then we're going to shoot the projectile from our gun to that same position, which means that wherever our collision is will be wherever our projectile will hit as well. It just will be coming out of our gun instead of out of our face. So let's go ahead and see what can we do to make that happen. Well, it's all going to be within our shooter controller script, so I'm going to load that one up. So a ray cast is going to require a lot of things, but we're going to want to do it whenever we click and shoot. So here's the code that we had already for shooting. For example, we've got our gunshot, we've got our projectile, we've got the manager, and the bullet that we're creating. So before we do all that, we're going to want to ray cast as well. And we do that by going to physics, physics.raycast. So the raycast method is going to require a number of different arguments. And so by pressing a comma, I'm able to see all the different arguments that we can use. We're going to want to use one of these arguments, which requires us to give it an origin point, which is the point at which the little laser is going to come out, as it were, the raycast. We're going to have a direction, which is a vector 3 as well, and then we're going to have a float max distance, and maybe we'll add some more arguments in there because we need to know, for example, where this hit point is, right? We need to know where this big X is as a position in the world. So we're going to start with working out where we're shooting it from. Well, we're shooting it from the main camera. This is where the laser should come out of. The laser should basically come out of our brain, our head, wherever we're looking. So we're going to have to make sure we have a reference to that object. So I'm going to go ahead and create a public transform. And this will be the camera transform. So we're going to call it camera. I'm going to save this. And now in the scene, I can go ahead and drag my main camera in and drop it. Oh, it hasn't appeared yet. Let me allow that to save. Oh, it looks like we've got an error. There's an argument missing. And because we haven't finished our raycast, I'm going to // to comment that out because it's trying to save and it says like, this doesn't make any sense. And it doesn't make any sense, but that's because it's currently in development. So now that we save, hopefully we won't get any errors. Okay, and now we can go to our player and we can see here's our camera transform, and we're going to drag our camera into that. So now that we've set it up in Unity, what we can use for our physics raycast is the camera.position, which is going to be the position of where our camera is, because that's going to be the first argument, which is where our laser starts from. So now we want to go ahead and think about the direction that our laser fires in, because that's the next argument. And we can see that whenever we press comma, we can see one of these ones that we can fill in is vector 3 origin, so that's the first one, and then vector 3 direction. So the direction that we want to shoot in is also to do with the camera, right? Because wherever our camera is facing is wherever we want to, is the direction we want to shoot the laser. We want the laser to come straight out, straight smack in the center of our screen. So we're going to grab the camera dot forward, and the forward vector is basically, it returns a normalized vector, which just means it's the magnitude of it is, it doesn't matter how big or how small the vector is, it just matters what the ratio of the x, y, z is, which is the direction that you're shooting in. So in this case, the forward is essentially this blue line. This is the forward of the camera, and that is the direction that we want. So we're going to go with forward. All right, so we've got two parts of our raycast. We've got the position that it starts from, and we've got the position, the direction rather, that it will go in. We're then going to want to go ahead and I'm going to check what the next thing we're going to use is. We want to use this raycast hit info. Now a raycast hit is a class variable, just like the way we've got a transform and a score manager and an audio source. So I'm going to go ahead and make that variable so that we can use it. It's going to be a public raycast hit. Oh, whoops, I need to make sure I stop making so many typos. Public raycast hit, and we're just going to call this hit. Keep it simple. And now for this particular argument, we're going to use the hit. Now, the interesting thing, this is a bit complex, so I'm not going to explain it too much, but essentially we want to write this out, because what that means is that whenever the raycast method executes, the information will be set within this hit value, and then we can use that hit to determine where the raycast actually hit. So it looks like there's a version of this that we can use where it's just origin, direction, and raycast hit, so that's fine. And we're not going to want these brackets here because we want to do this every time. Every time we shoot, we want to do this raycast. So whenever we raycast this, what we're going to have is this hit value. And this hit value has a position. We can do point, it's called. And what this point is now is the information of where we just shot. So what are we going to want to do with this information? Well, let's start by just debugging to see if this is working as correctly, which means I'm going to go ahead and create a new prefab, which will be like a hit prefab. Because before we do any more funky stuff, it's important that you test your code to make sure that it works. So just like we make a new bullet and fire it, I'm going to go ahead and copy this code and paste it here, but instead of making a new projectile, we're going to make a new hit prefab. And then we're going to go ahead and set the position of the hit prefab that we just made. Sorry, not the new bullet, it should be called something else. It should be called new hit. So make sure that you change that. And now we're going to go new hit dot transform dot position is equal to hit dot point. And I'll show you why this is important. You maybe have guessed what it is we're trying to do here. Essentially what we're trying to do is we're trying to make sure that wherever we shoot is where this object will appear, which will be a debug for our raycast. So we're going to have to make something that can spawn in. So I'm just going to make something really simple here. We're going to make a sphere. Here it is. Looks about the right size. We're just going to go ahead and stick that into our assets folder as a prefab. Now it's called sphere. I'm going to zero out these positions just because it's a good idea to do that with your prefabs. And then finally, we're going to have to make sure that we remember to drag our sphere prefab into our variable. Now the variable isn't there because I haven't saved yet. And whenever I try to save, it looks like there's an error. There's an invalid curly bracket. And let's see, it looks like for some reason I've got two curly brackets up here in just after public class. I don't know how that happened, but that's why it's always important to save your script and then look and see, are there any debug log errors? And these are warnings, so we're going to ignore those. And now we can see our hit prefab has appeared. It says none game object because we haven't yet told it which object we're using. We're going to use the sphere object. So now let's see what happens whenever we shoot at things. Whenever we shoot, the raycast is sending out that little red laser, and you can sort of see the sphere is appearing wherever our raycast hits a particular object. Huzzah! So this looks like it's working. I mean, we can just create an infinite number of spheres, but that's not the point. The point is we're now going to use this instead of creating a sphere, because that was just a debug. We're going to instead use it to determine our prefab, our bullet, what direction it's shooting in. So how do we do that? Well, let's see. The first thing we're want to do is not spawn our sphere anymore. So I'm going to go ahead and comment out this part here, 2 forward slashes and then 2 forward slashes here. And that's because that was just to debug. We don't actually want to spawn a sphere wherever we shoot. Instead, we want to use this hit.point as the information for where our projectile should move towards. Now, our projectiles shouldn't appear in our head anymore. They should actually appear at the muzzle of our gun, if that's what it's called, or let's see. I don't know my gun terminology too well, I'm afraid. But you know, at the end of the gun, the barrel of the gun, perhaps it is called. So I'm going to make another little cube here, but this time I'm actually just going to get rid of these elements here. We're going to remove all these components. So you could have not made a cube. You could have just made an empty game object there. And we're going to position it at the front of the gun. And we're going to use this position as the position to spawn our projectiles. So how will we know about it? Well, that means we're going to have to use a public transform again. So we're going to make another public transform. This one's going to be called something like the end of the gun. And we can look at our code for spawning in a billet. Here's the billet that we're spawning in, and here is where we set its position. So instead of, oh, we've already done this, we've already got the spawn transform. So pretty straightforward. We can in fact not do this. Let's get rid of this end of the gun, because we've already done this in the code. We've already got a spawn transform. That's fine. So now all we need to do is change the spawn transform. The spawn transform before was the main camera, but now we're going to change it to this object that we just made, which is the end of the gun. So you'll see sort of like the problem we've created now, which is that whenever we shoot our guns, whenever we shoot our bullets, they sort of they aren't going in the right direction. They at least are appearing at the end of our gun, and you can kind of see that, right? You can just about see the bullet flashing up just at the end of our gun, but it's not going in the right direction, even though it starts in the right position. And that's because we're setting the rotation equal to the spawn rotation, but we don't want to do that. So let's change this to instead change it to a direction that points towards our hit.point. So we're going to do this by using vector 3. And we're going to go vector 3, let's see if I can remember what we're going to do here. Are we going to use transform.lookat? Yes, let's use that. So instead of setting the rotation directly, we're going to use this lookat, which is going to calculate the direction for us based on a particular target. The target in this case is our hit.point. This is the point where the raycast collided with something. So I can go ahead and build, and let's see if this works. I have a feeling something will go wrong because it almost always does, but we can try and debug the problem. So we're shooting something, but then our projectile just sort of disappears. So what's the problem here? Well, let's go ahead and see if we can find some of our bullets. But it looks like the bullets are just like instantly disappearing the moment that we shoot them. And I think what's happening is that our gun, our bullet, is actually colliding with our gun. That's my theory, because whenever our bullet collides with something, it disappears. Our projectile, you can see here, if it's not equal to the player, then it's destroyed. So we're going to have to make sure that our gun is also equal to player tag. And that way, whenever our projectile spawns inside the gun, it won't immediately disappear. Aha, there we go. And so now our projectile shoots out of our gun, and it shoots out towards the direction of where our cursor is. So now I think this looks a lot better than whenever it was coming out of our head. Now it's like we're actually firing it out of our gun. And it looks very slow. We can always change the speed. But we've now sort of not actually changed any of the mechanics of the game. It's still the same thing. You look at things and you click to shoot them, but we're changing the visuals. And changing the visuals of a game is a big part of animation. It's a big part of design and art, but it's also programming. There's a lot of things that you can do in programming to change how your game feels to play. So hopefully you've been able to follow this tutorial, and if not, if you get stuck, then as always, just send me a wee email and I can see what part you're stuck on, and I can maybe give you some tips on how to get unstuck. I always try and do these tutorials without doing a lot of prep, and that's because I want to show you guys not just how you make something, but also how you fail at making something. You'll always encounter bugs, you'll always encounter problems, and it's often a case of trying to work out what those problems are. There's quite a few common bugs that you've maybe experienced now. For example, if you're saving, if you forget to save the game, your variable won't appear and therefore you won't be able to set it. Or if you forget to set your variable in Unity, it will come up with the null reference exception error. Anyway, talk to you soon and see you in the next tutorial.